the cells and also connect the tendon to the bones, and or by ligaments connect one bone to another bone. For support and movement, the bone is one type of the connective tissue. Storage, the fat tissue or adipose tissue. Insulation is the function of the adipose tissue. Transportation of something is the blood. All of these are different type of the connective tissue that in the last of this session we know about them. But this is a tissue. And for studying and knowing about the tissues, we should study and know two components as cells and extracellular matrix. The ECM also included the fibers and ground substance that we know about these three components. Extracellular matrix included the fibers and ground substance. The fibers in the connective tissue included the collagen, elastic or reticular fibers. The fibers in the connective tissue composed of two types of proteins. Yes, this is the proteins as collagen or elastin. Yes, this is the type of proteins. That the elastin proteins form the elastic fibers. And the collagen proteins, collagen fiber, the collagen fibers have 28. The elastic just have one mature one and the second one is immature. But the collagen fibers have a lot of color. Ground substance included the fluid as water and also some combination of the macromolecules, carbohydrate, the proteins that now about them. At first, about the cells of connective tissue. The cells are in connective tissue have two derivations. Some of them derived in the embryonic period from one type of the cells that named mesenchyme cells. In the embryo, as small of us, yes, the embryo, most part of the embryo included the mesenchyme cells that they form one type of tissue as mesenchyme tissue that have a flat nucleus with lots of cytoplasmic process. The mesenchyme cells differentiate two cells of different type of connective tissue. What is the different type of connective tissue? Proper, bone, cartilage, blood, lymph, adipose. All of this tissue cells derived from mesenchyme cells in the embryonic period. But there are other type of the cells in the connective tissue that derive from bone marrow. Which type of the cells? Hematopoietic cells. Some of the cells that are in the blood, such as neutrophil. The neutrophil just are wandering in the blood, don't have any function in the blood. Its function is in the connective tissue. Lymphocytes also. They are in the blood, but when they want to do their function, they migrate to connective tissue and do their function. These type of the cells derive from bone marrow. The mesenchyme derivation, as I said for you, the cells that are in the cartilage, adipose tissue, in the bone and in the proper connective tissue. All of these derive from mesenchyme cells. As you see here, all of them have chondroblast, chondrocyte. Here is right, adipocyte, adipoblast, fibroblast, osteoblast, osteocyte. Do you know the difference between blast and cyte? We have lots of them. Most of the cells have most of them. Blast are immature type of the cells. And then also in connective tissue, bone, cartilage, and adipose tissue as blast. These cells that are in the different type of connective tissue derived from mesenchyme cells and are resident cells in connective tissue. They birth in the connective tissue and die in the connective tissue. But the second type, bone marrow derivation, these cells are transient cells. Their birth is in bone marrow. Do you know the bone marrow? Yes, in the bone. There is a cavity that named as bone marrow cavity that included the bone marrow. Bone marrow included the hematopoietic stem cell and also mesenchyme stem cell. They are transient, and these cells, yes, birth in the bone marrow, but they die in the connective tissue. Just they are in the blood. That, as you see here, included different type of the cells in the blood. You know them as blood cells, as different than the RBCs, different type of the white BC that we know about them in the blood session. But the cells of the connective tissue, proper connective tissue, not different type of them, because you know about them in the another session. Now we want to about the proper connective tissue. The most abundant cells are in connective tissue are fibroblasts, and its name they involve in the synthesis of fibers. Fibroblast. Yes, the blast or cells that involve in the production and synthesis of the fibers. Which fiber? All of the fibers, collagen and elastic fiber. Also, they involve in the synthesis of the ECM or extracellular matrix. In the tissue section, the fibroblasts have oval-shaped nucleus and purple. It shows that is involved. The purple color, blue color, show the activity in the protein synthesis. Developed RER and ribose. But mostly in the adult tissues such as tendon, such as the ligament or the proper connective tissue, in most part, the fibroblast finish its function and change to the fibrocyte. Fibrocyte is a type of the mature one that regress the organelles, the nucleus, and mostly under microscope they have a flat nucleus. Fibroblasts are active cells in the protein synthesis and also ground substance are in the connective tissue. They are very big cells with distinct nucleus, lots of cytoplasmic process and also well-developed organelles that involve in the protein synthesis as RER, Golgi apparatus, mitochondria or others. In the cell culture, when we culture them in the lab, in vitro, they have lots of cytoplasmic process and distinct nucleus. And this picture shows one fibroblast under electron microscope, scanning electron microscope. The fibroblast is most important, most abundant cells in the proper connective tissue that synthesis the ground substance and fibers. Maybe it's one of the questions. Macrophage. Macro means big. Phage means eating. They are very big cells that eat something. They involve in the removing of the bacteria, microorganisms, the harmful materials in our body. They are in the connective tissue. We can identify them very easily because they are biggest cells in the connective tissue. The biggest one. Destroy the bacteria, active in the immune system and also in the immunity, and also phagocyte the apoptotic cells, also the cells that removed by apoptosis. Previously named them as histocyte, around maybe 100 years ago because they are big and are the first cells that discovered by the biologists. Under electron microscope, they have irregular surface. They have some protrusion and invagination because they form some pseudopedia for engulfing of the bacteria and macroorganisms. And also, yesterday I explained for you about the lysosomes. That the lysosomes involved in the digestion, and the cells also involved in the digestion have more lysosomes. When they lysis anything, finally the useful materials used by cell and the harmful materials accumulated in some vesicles that finally as waste removed from the cell or no. When the cell die, they also remove. Because of it, we can find lots of granules in the cytoplasm. Macrophage is one of the cells that are in connective tissue, but they burst in the bone marrow, then go to the blood as monocyte, that are the biggest cells in blood cells, and then they migrate to other tissue. The monoblast differentiate to monocyte in the bone marrow, migrate to blood. We can find lots of them in the blood. But for their function, they should migrate from the blood to other tissues. They form lots of type of the macrophage with different name, but functionally all of these are macrophage. Yes, that lysis and remove and restore the bacteria, microorganisms, waste materials or what. But just their name is changed. In the CNS, the macrophage of the CNS named as microglia. In the liver named as Kupffer cells. In the lung named as alveolar or dust cells. In the bone, osteoclast, and in the skin they named as Langerhans. Some books, they have some classification or some chapter as mononuclear system. It's a system that included some cells that have one nucleus, but all of them are involved in the phagocytosis. Maybe this is one of the questions. For example, the Kupffer cells is in which organ? Or for example, the Langerhans in which organ or which layer? Because you know about the skin also is a little in this table show the different type or different name is better that I said. Different name of the macrophage and their location. You can also just study this table, not this one, because more of them involved in the removing of the waste materials. Schematically show the macrophage that, as you see, lots of pseudopedia that can engulf, and finally, as the endocytosis, these microorganisms enter to the macrophage and digest by the lysosomes in the macrophage. Mast cell derived from bone marrow because the mast cell is a one type of the blood cells that they are large cells, but this cell also, when want to do its function, should migrate to connective tissue that involved in the allergic conditions. Cytoplasm included lots of cytoplasmic granules that triggered by antigen. In the allergic condition, different, for example, I don't know, some poison, some for the flowers, yes or no, maybe some foods that we have sensitivity to them. Yes, all of these are antigens that attach to the receptors that located on the surface of the mast cell, as said yesterday. The ligand attached to its receptor activate some cascade in the cell. These granules released that these process named as the granulation, and they finally trigger the antigen. The mast cell have one specific property that are not in other cells, named as metachromasia. Metachromasia is a occurred in the lab when we do a staining with the blue dye, as hematoxylin, for example. Yes, they are blue dye. But in the metachromasia, when we stain as blue, yes, we have under microscope also blue stain. Metachromasia occurred in the mast cell. When we stain with blue dye, they stain show as red color. These changing of the color under microscope named the metachromasia. Meta means changing of the color of the dye. That is specific in the mast cell. We can identify by these the mast cell from other cell. Another question. The metachromasia is the specific structure for which cell? For example, plasma, basophil, eosinophil, or others. They included some granules that contain the histamine, heparin, and other some proteins or others that finally they resulted to the reaction to different allergens. That, as you see here in this picture, different allergens that are in the food, in the air, or in our environment, attached to the immunoglobulin E that are in the blood. These immunoglobulin have receptor on the surface of the mast cell and also on the basophil, that is the blood cells. When they join together, they activate some kinase, some cascade inside of the cell, and finally the granules that included heparin, histamine, some chemotatic factor released from the cell, and these materials have receptors in different organs. For example, histamine have receptor on the mucosal layer of the respiratory system. Resulted to rhinorrhea. Have receptors on the isthmus muscle of the respiratory system. Contract them. The person that suffered from allergic condition maybe have dyspnea or difficult breathing. Have receptors on the blood vessel. Relax them and their blood pressure fall down. Yes, in these persons that each of they have a different function. Just now, because in the immunology you know about it's small. Just now about the origin of the mast cell, location of them, and also the function of them. They produce they have granules that involve in the allergy. Plasma cell are other type of the cells in connective tissue. Again, these cells derive from bone marrow and migrate to the blood. The precursor of them are B lymphocytes in the blood. When they migrate to connective tissue, their name and their function change. We name them in the connective tissue as plasma cell that involved in the production of the immunoglobulin. Immunoglobulin are type of the proteins. Because of it, these cells have a very distinct basophil nucleus and also lymphocyte. A specific characterization in the plasma cell is a pattern of the heterochromatin and euchromatin. Yesterday we talked about that. That in the mast cell, they form a pattern as clock face, as this. The number of the clock are heterochromatin, and the page of the clock is the euchromatin. We say that the pattern of the chromatin in the plasma cell is as a cartwheel or clock face. That is a specific structure of the plasma cell. Another question. The clock face pattern seen in which cells? Or, for example, what is the specific characterization of the plasma cell? For example, the cytoplasmic granules or the big, the other cells, cloud phase, metachromasia, yes, that is cloud phase for the plasma cells. Leukocyte, different type of the white PC, as neutrophil, eosinophil, basophil, monocyte that I explained about it, and lymphocyte are 5 type of the white PCs, are blood cells. All of these cells can and should, except the lymphocyte, must migrate to connective tissue and do their function in the connective tissue. Because of it, they are the cells of connective tissue. When they migrate to connective tissue, do their function and die in the connective tissue. Sometimes maybe without any function they die. For example, in each day, in all of us, around 1 million neutrophils die without any function, because when we are safe and don't have any ill, yes, they don't have any function. Just wander in their body and finally die in the connective tissue, except the lymphocyte. Then do its function and can return again, come back to the blood. That we know about them in the blood session. Adipocyte, fat cells, are another cells that are in the proper connective tissue. They are some white color cells, polygonal cells that are also, we can see them in the connective tissue. These cells included 1 droplet of the fat, lipid. As mucous material, the fat lipid also in the slide preparation dissolved in the alcohol and xylem. Because of it, the cells don't have any cytoplasmic component. They don't have any stain, and under microscope we can see them as white color, that we know about them in the adipose tissue. Yes, here there is a table that shows the cell types of the connective tissue, their function, and also their location, that they are in which part and what is their function. And this is useful for you, because briefly explain about the connective tissue cells. The other part of the connective tissue is ECM, or extracellular matrix, that have 2 components, as fibers and ground substance. The matrix fibers have 3 types, but they included 2 types of the proteins. Collagen fibers and reticular fibers, both of them, its subunit included the collagen proteins. But because the reticular fibers are more spare in our body compared to other type of the collagen fibers, some books divided them as third type of the fibers. Collagen fibers, reticular fibers, included the collagen proteins. They are more abundant in the body, mainly collagen type 1. But the elastic fibers included the elastin proteins and are in some organs that need to the stretching and also relaxing. Collagen fiber fiber as this. Yes, the fiber have more thickness. Sorry, I forgot the name of the English word of the fibril. Collagen fibers in our body are as fiber with more thickness. Fibril with thin thickness, or they form a network. They are not located regularly or parallelly together. They are as same as a network that are in the ECM. Here, this table shows the important or well-known collagen types. 1, 2, 3, 4, or others. The form of them. As you see here, collagen fiber type 1 form a large banded fiber. Lots of collagen fibrils aggregated together form a group of the fibrils and form a fiber. Collagen type 2, 3, or 5 form a fibril. Yes, they all have a thin thickness. Collagen types 4 that I explained in the basal surface of epithelial tissue form a network, or they are as sheet-like. And some of them are fibril associated that we know about them in other tissues. Their location, there are them that again we explain the importance of them in the other tissue. That's you now. The collagen type 1 are more about them. As you see here, they synthesis by different cells that derive from the mesenchyme cell. The fibroblast, chondroblast, and where is the osteoblast? Because collagen type 1 also is in here, the osteoblast. That explained for you about the difference between the fibers and fibrils. That the diameter of the fibril are very few compared to the fiber. Network, they located in different direction and form a framework for the other cells. We can find them in some cellular cells. Anchoring collagen type 7 is the anchoring fibers that other fibers attach and anchor to itself. Fibril associated collagen, they are structural proteins. They help to other collagen that synthesis and maintain their structures. We can see this type of collagen in cartilage, type 9 and type 11, that can form and maintain their collagen type 2 in their cartilage. The collagen is a type of the protein. Yes? Yesterday I explained about the synthesis of the protein in the ER. Yes? As you see here, the mRNA ribosome subunits transfer from the nucleus by nuclear pore to the cytoplasm because they have the signal peptide, yes, recognized by signal peptide particle attached to the RER, and then they come into the lumen of the RER, and the peptide of the collagen growing inside of the RER. That I explained yesterday, yes? But as I said for you yesterday, some of the post-translational modification sometimes occurred in the lumen of RER as collagen synthesis. The hydroxylation of 2 amino acids as proline and lysine occurred in the lumen of the ER. Then they, again, after the oxidation of these 2 amino acids, they assemble together another post-translational modification and form a triple helix of porocollagen. Porocollagen is an immature type of collagen. This porocollagen as triple helix packaged in the Golgi apparatus cytoplasm. The collagen fibers, yes, must not remain in the cytoplasm. Should exit from the cell and go to the ECM. Collagen is a component of the extracellular matrix. The procollagen come to the cytoplasm. The procollagen included here, just for your knowledge, some peptide, that this peptide prevent of the elongation more of the collagen fibers and remaining of the collagen in the cytoplasm. After exocytosis to the cytoplasm, this peptide removed, the propeptide removed and formed the mature collagen. As you see here, the mature triple helix of the collagen don't have this peptide. It is removed by one enzyme of the lysosome as peptidase. When this part removed from two ends of the collagen, again they assemble together and form the collagen fibers or collagen fibrils. That the one thing is, yes, is important, this one, that hydroxylation of them occurred in the ER. The second one, they formed a triple helix procollagen in the ER, and these peptide removed from the collagen fibers in the ECM. This is very, very important because if this not occur, they remain in the cytoplasm and finally result to the fibrosis. Fibrosis means the accumulation of the fiber in the cytoplasm of the cell. And finally, after removing, they form some link together and form the mature collagen. Collagen type 3 or reticular fiber form a reticulum. Reticulum is as a network that, as you see here, they are fibril, very thin fibers located in different directions, and we can see the reticular fibers in the cellular organs, the organs that included lots of cells, such as liver, such as glands, such as lymphoid tissue. The cells should have seat in the organs. Yes? Sorry, I example you. Yes? You are students. You are as same as to the cells. You need some seat that's sitting on them. These seats are reticular fibers. Reticular fibers form a situation for the sitting of the cell. As this chain that are reticular fibers for sitting of you as cells. Okay? That we can see them in the cellular cells. They synthesis by fibroblasts, and also there are some fibroblast-like cells that just synthesis the reticular fibers. We name them as reticular cells because the reticular fiber is a type of collagen produced by the fibroblast. When we stain them by the silver, the dyes that included the silver or chrome, they also have affinity to them. Because of this, also named as the argyrophilic cells. Just not important, just now about it. The other collagen types, for example, the 1, 2, or others, yes, not very important for you. Just I explained about the collagen type 1 and 3 that are more important, and also in your book explain about them. Elastic fibers, composed elastin protein, that this protein assemble as coiled structures and finally form the elastic fibers. Elastic fibers under microscope have a wavy structures. You can see them in the next session. You can see them in the aorta. There are lots of elastic fibers in the aorta. This glycoprotein is important for the formation of the elastic fibers. It means if these proteins this sufficiency of these proteins occur or no mutation of these proteins occur, the mature elastin not synthesis in the body, such as there is a syndrome as Marfan syndrome. Some person suffered from the hereditary disease that they don't have mature elasticity and they, because of it, they don't have any stretch in their, for example, aorta or other organs. This is not important, that's important. Ground substance. Interstitial fluid. 80% of the ground substance included the water and also gas or glycosaminoglycan and the combination of the proteins and carbohydrates. What is these are? The gas are repeated chainy structures of polysaccharide. A lots of, yes, glucose is a simple form of the carbohydrate. Yes, they arrange and mix together and form a complex of the carbohydrate that we name them as polysaccharide, disaccharide. Disaccharide mean they have two chains. Yes, polysaccharide, they have a lots of chain of the saccharide. Saccharide is a complex form of the glucose. In the gas or glycosaminoglycan, there are a lots of carbohydrate chain. The main structure of them is the carbohydrate or glucose. The carbohydrate have high affinity to water. They absorb a lot of water. Thus, the part of the organs of our body that included the gas also included a lot of water. Because of it, they can act as a good lubricant. They are in their cartilage. They are in cartilage, included a lot of gas and also a lot of water. The common gas in connective tissue is hyaluronic acid. The hyaluronic acid is more abundant of other type. Also, there are other type that you can see their name. Maybe this is one of the questions. The most abundant of the gas. When the gas or polysaccharide chain join to one protein, name this as proteoglycan. That the amount of the carbohydrate are more and more than protein. Yes, that have some parts. This protein mostly attached to the hyaluronic acid because the hyaluronic acid are more abundant as this. Glycoproteins. The proteins are more. Yes, both of these are combination of the protein and carbohydrate. The second one is more. Here the gas or carbohydrate are more and the glycoproteins, the proteins are more. Some chain of the carbohydrate attached to the proteins. There are different type of them in different type of the connective tissue. Fibronectin in the connective tissue, in proper connective tissue. Mostly they act as some peaks, act as a glue that attach the cells and fibers to ECM. Yes? Fibronectin is act as a peak for the attachment of the fiber to ECM. Chondronectin in the cartilage. Osteonectin in the bone. And the laminin that is in the all of the basal lamina and base membrane of the cell. Another question maybe, for example, the chondronectin located in which tissue? Interstitial fluid is a water that you know the most part of the blood also included the water that plus the proteins we name them as plasma that in the vessels of blood and also in the interstitial space included the water. They form two types of the pressure as prostatic pressure in the blood, osmotic pressure in ECM. And these two pressures should be balanced. The next part is the type of the connective tissue. Different type of connective tissue are in our body. How we classify them, that I explained for you. I think we have around 5 minutes. Is okay? Just a little you go and come back. But come back soon.
It's 5 minutes, 5 minutes. We don't usually see 5 minutes. يعني احنا نجح بخير كم مثلا؟
خليني كمان. Just about 10 minutes. 10 minutes, come back that I explained about the connective tissue and a little around I think 15 minutes. I tell for you the adipose tissue and the blood also is for me that in the Saturday we know about. As I said for you, the connective tissue are more spread to our body in different parts and because of it they form different type of tissues based on the type of the cells and the amount or the type of the ECM. The first classification is on the base of this tissue location in the embryo or in the adult person. That divided in two parts as embryonic connective tissue are just in the embryo, not in the adult person. But most of them are adult connective tissues. The type of connective tissue in embryo are mesenchyme tissues and mucous tissues. And the adult connective tissue are proper and also the specialized connective tissue that now we know about the proper and the specialized we know them in the other session. The proper connective tissue, also named as the one type, yes, the proper type 1, divided to loose connective tissue, dense connective tissue, and specialized. The specialized are the adipose tissue, bone, cartilage, and blood. Yes. Proper tissues divided to loose and dense. What is difference between of them? Difference of them is based on the amount of the collagen fibers. In the loose or areolar connective tissue, that is most common in our body, in all parts, around the vessels, around the organs, yes, the organs that are empty and filled, for example, around the stomach, the esophagus, or others, they form a dead space for the expanding of these tissues. They are most abundant. The number or the amount of the cells, fibers, and ground substance are equal in these tissues. One cell, cells, one cell, fibers, one cell, ground substance. In the loose or areolar connective tissue. The cells are connective tissue as fibroblast, macrophage, or others are them. The collagen fibers, reticular fibers also are more there. Where there are? In the subcutaneous layer of the skin. That form the superficial fascia. Mucous membrane around the blood vessels, nerve and body organs. All of these occupied by the connective tissue, including all three fibers, collagen, elastin, and reticular fibers, and also different type of the cells. Under microscope, they have a white color because of the ground substance don't like the dyes, don't have affinity to hematoxylin and eosin. You can see them. The ground substance is white color, the cells are spare, and the collagen fibers have pink color under microscope. There's connective tissue. There, collagen fibers are more and more compared to the cell and ground substance. If the collagen fibers located parallel together, named as regular dense connective tissue. If the collagen fibers are located in different direction, named as irregular dense connective tissue. Dense connective tissue, collagen fibers. Under microscope, collagen fibers a full bone. The ligament attach one bone to another bone. The tendon, in all parts are dense, regular connective tissue. But ligament in some parts are regular, some parts are irregular. Under microscope, we can see lots of collagen fibers. Collagen fibers under microscope form as a bundle. We can see a background of the pink color that between of the fibrocyte located parallelly together, because the fibrocyte finished its function, they finished the collagen synthesis, regressed, and changed to the fibrocyte. Fibrocyte have flat nucleus that located between the collagen fibers in the tendon and ligament. In the irregular connective tissue, the collagen fibers arrange irregularly. Some of the ligament in the dermis layer, we can see some collagen fibers that are in different direction. For example, these are direction difference to these one. Reticular connective tissue. The reticular fibers are dominant. I explained for you. We can this type of tissue in the cellular organs. The example of you and seed. Yes? That we can find them in these organs that are included in lots of cells, such as lymphoid tissue, in the liver, in the exocrine glands. We can find them that the fibroblasts and reticular cells produce the fibers. The dominant fibers are reticular fiber in reticular connective tissue. Embryonic connective tissue, the adult connective tissue as cartilage bone or others have a separate section. Embryonic connective tissue have two types. Mucous tissue found in the Barton gene. You know the Barton gene? In the embryonic period, yes, embryo is in the uterus, yes? The routing is very bad, sorry. And the embryo connect to the mother circulatory system by a ground organs as placenta. That in this cord that made the embryonic cord included the vessels and artery and vein that change material between the embryo and mother. These vessels surrounded by a white membrane that named gigabyte. When you see the fresh umbilical cord, around of it there is a white membrane that named as Barton gene that included the mucous connective tissue. What is the characterization of mucous connective tissue? One question maybe. The ground substance are more, especially hyaluronic acid. It means the ground substance are more and more than cells and fibers in mucous connective tissue. Mesenchyme connective tissue is a backbone of the embryo. Embryo, in the first of 2 months, included mesenchyme tissue. What is the mesenchyme tissue? Included a lot of mesenchyme cells. That these mesenchyme cells finally differentiated to different type of connective tissue, as skeletal bone, as cartilage, as blood, as adipose tissue. All of these derived from the mesenchyme tissue. It's the source of all adult connective tissue that are more part of the embryo. It's a backbone of the embryo is from the connective tissue. Another question. But is these tissues form the backbone of the embryo? Mesenchyme cell